project is carried out to determine the properties of specific material that fits the criteria of modulus of elasticity 169 GPa and density of 7.1 GCC. Modulus of elasticity is a quantity that measures the resistance of an object to elastic deformation when stress is exerted on it. It is also described as the stiffness of a material and known as Young's modulus. Modulus of elasticity is also expressed as the ratio of tensile stress to tensile strain with formula E equal to sigma over epsilon. Density is one of mechanical properties of materials which is calculated based on mass of a unit volume of a substance. It is usually expressed in units of grams per cubic centimeter. The formula of density is mass over volume, and the higher the mass of a sample, the denser the material is. Density is a property that allows floating and sinking of a material. When two or more substances are mixed, the denser material will sink to the bottom, while the less dense material will float. It is also possible to consider density as how compressed and compact a material is. The first objective is to determine the suitable sample of unknown material from the given data. The second objective is to propose mechanical testing of the mechanical properties. The sample materials that we found to fit the criteria given are ductile cast iron and silicon. Ductile cast iron is a metal. Metal is one of materials that has high thermal and electrical conductivity, ductility, malleability, and high light reflectivity. The absence of a layer of atoms in metal's closely packed structure allows it to plastically deform and stops it from becoming brittle. Metal can be classified into metal alloys and metal. Metal alloys is chosen as one of the samples for this project, which is ductile cast iron. Metal alloys are normally manufactured through heat treatment or by alloying the metal. Silicon is a metalloid. Metalloid is a term used for elements that are better than non-metals but not as strong as metals in conducting electron flow, also known as a semiconductor. Metalloid atoms may either enhance or obstruct the movement of electrons. The other sample in this project is a metalloid, which is the silicon, an element that falls between metal and non-metal. The ductile cast iron has a grade of 60, 40, 18 with ASTM A536. It is a solid metal specimen produced from molten ductile iron and solidified in a mold. The maximum percentage of composition of this iron are 3.8% carbon, 0.3% manganese, 2.5% silicon, 0.08% chromium, 0.5% nickel, 0.2% copper, and 0.055% magnesium. As for silicon, this metalloid is an anisotropic crystalline material in which the properties of materials depends on orientations relative to the lattice of the crystal. Silicon specimens tested in this project are the one with 1-110 directions. To test the modulus of elasticity of the samples, tensile test is conducted. A tensile test is a fundamental test in material mechanics. It is performed by pulling a sample of material apart until failure while measuring the force and displacement. It provides us with something called a stress of a strain curve. In this scenario, the stress is defined by the force applied to the test sample divided by the cross-sectional area. This gives us units of newtons per meter squared, which you may recognize as the metric units for pressure pascals. Stress goes on the y-axis. Strain describes how much deformation has occurred while the applied force, and it is found by dividing the change in length by the original length. Strain is placed on the x-axis. Let's watch this test again and see what deformation we can get from the stress of the strain graph. As the stress rises, the material begins to deform. This initial linear region is elastic deformation. That means that if we remove the force, the material regains its original shape. Think of how a rubber band can be deformed hugely and still come back to its original shape. The end of this linear elastic deformation is marked by the yield point from here. without any additional stress will cause permanent deformation. This is called plastic deformation. The stress continues to rise until it hits the ultimate tensile stress point. This is the ultimate strength of the material, the more stress it can handle. From here, less stress is needed as the material begins to decrease in cross-section, which you can see happening here. This is called necking. This continues until the material fractures. To test the density of the materials, density testing is done. Density of the materials can be calculated by using the formula density equal to mass over volume. The weight can be obtained by following the steps. First, prepare an electronic weighing scale. Second, calibrate the scale until it becomes 0 by pressing the tail button. Third, place the metal on the weighing scale. Fourth, record the mass. Fifth, repeat steps 2 until 4. Lastly, record the average mass in gram. The volume of the material can be obtained by using a water displacement method. First, prepare a 1000 ml graduated cylinder. Second, fill the graduated cylinder with water and record the volume of the water. Third, put the metal in the graduated cylinder until it is fully immersed. Fourth, record the final volume of the water. And lastly, use the formula volume of metal equal to water initial volume minus water final volume to find the volume of the metal. Find the density of the materials. The mass obtained is divided by the volume obtained. As a result, from the tensile test, the modulus of elasticity for the ductile cast iron is 169 GPa, while for the silicon is 169 GPa. As for the density for the ductile cast iron is 7.1 GCC, while for silicon is 2.33 GCC. In conclusion, the best material that fits the criteria given is ductile cast iron, as it has the modulus of elasticity of 170 GPa and the density of 7.1 GCC. This is the end for our video. That's all from us. Thank you for watching.